shoes. I put on my socks and shoes.
Today we will see this funny little property, socks shoes property, and in the video I will say why this property has this funny name. Before going to the property, let us see real numbers under the operation of multiplication. We all know a b to the power n equals to a to the power n b to the power n. We all are familiar with this property, but in groups we don't have this property. We have something for inverses. Inverse of a product is same as product of their individual inverses but in opposite order. B inverse A inverse. It is in any group G with two elements from that group, we have this property. And this property has this funny name because when suppose you are getting ready to go out, you first put on your socks, then your shoes, but when you come back and you take off the things, you first take off your shoes, then your socks. So you are reversing the order. So suppose this is putting your shoes, socks on first, then putting your shoes, and you are doing the inverse, undoing the things. You will first take off your shoes, then your socks. So that's why this property has named socks shoes property. And now we'll try to prove this my little theorem. And proving this theorem is very easy. We'll first multiply this one with AB and we'll check if we were finding identity or not. This is same as AB, B inverse, A inverse by the property of associativity. And this is same as A identity A inverse, and which is same as A inverse. I can operate E with any one of this element A and A inverse by the property of associativity. And this is same as E, where I have taken E as the identity, is the identity of G. So when B inverse A inverse is multiplied with AB in the right side, I am using the terms product multiplication, but these are the notation, multiplicative notations. We are dealing with a group and the operation can be anything. The elements can be matrices, elements can be sets, elements can be anything. But the operation here is the operation of group, and the operation can be anything. It is not usual multiplication we are familiar. And we'll show the other way. B inverse A inverse when operated with AB will also find identity. This is same as this one by associativity. And this is equals to B inverse identity. I have taken E is the identity, and I can operate E with anyone by the from associativity property. And this is same as B inverse B, which is equals to E. So in any way we are finding AB times this element is identity, and by the uniqueness of inverses, we have AB inverse is same as B inverse A. Uniqueness of inverse is saying for any element we can have only one inverse. So inverse of AB can be only one element, And here we have found AB when multiplied with this element, we are getting identity, which is the property of inverse. So this is the inverse of AB. So inverse of AB is B inverse A inverse, because this element when operated with AB in any way, it is giving identity. And uniqueness of inverses is saying we have only one inverse for one element. So we have proved this cute little property, and in general we can say, in general we have, suppose we have n number of elements, all these elements are from our group, and we are trying to find the inverse of this element, where we have operated A1 with A2, A3 and so on up to An. So we have n number of elements, A1, A2 up to An, and they are operated with the operation of group G, and we are going to find its inverse. This inverse is same as inverse of their individual, the product of their individual inverses, but taken in opposite order. This is not same as A1 inverse, A2 inverse, A3 inverse up to An inverse. So this is the Sachs-Schulze property in general. You can also show this one by, this proof is by repetitive use of Sachs-Schulze property. We can have this one. We can prove the general case. We have A1, A2 up to An. I can group this one as single element, and this one is another element. Finding its inverse is same as inverse of this one. I am doing this one by the property of associativity and by Sachs-Schulze property. What we have? We have, this is A, this is B. Inverse of AB is same as B inverse, and this is A inverse. Now we shall again use the Sachs-Schulze property for this thing. We will group A1 up to An minus 2 as one element, and An minus 1 as another element. So this is A, this is B, and we are finding the inverse of AB, and this is same as An inverse B, An minus 1 inverse. Then we have whole this one, A1 up to An minus 2 inverse. By using the Sachs-Schulze property successively, we can show that this is indeed equal to this one, and we have already found An inverse here, An minus 1 inverse here, and successively we can find all other elements up to A1 inverse in the last. So we have in general the Sachs-Schulze property, product of, suppose we have multiple elements, inverse of their product is equals to their product of their individual inverses but in opposite order. So this is in general the Sachs-Schulze property. So this is our Sachs-Schulze property in general, and this can be proved by repetitive use of the Sachs-Schulze property. Thank you.